Dear learners, today we have a discussion on chi-square test and its various assumptions. What is chi-square? Have you heard the name chi-square? Before going to the test chi-square, I would like to discuss what is a variable. Variable is what we consider in research. Whatever it is, we call it as a variable in a research study. It's a major concern in research. Variables are major concerns in research. Similarly, we can say that whatever we value in our research study, that is a variable. Why I discuss this? Because when we talk about chi-square, we should know what is a variable, what is a level of measurement of a variable. In that context, I have discussed what is a variable. So you have lots of variables. Can you name some of the variables? Let me write some of the variables. Sex category, it is a variable. Locality of residence, generally we consider in educational and psychological researches. Locality of residence. Family, type of family, we consider this also as a research. Birth order we sometimes take into as a research. Type of management of school, type of management, this sometimes we look into as a variable. These are also variable, these are all variables. Some of the researchers, they have seen that religion, they take religion as a concern in their research. Socioeconomic status, SAS, I mentioned socioeconomic status as a variable. Marks or numbers, marks in a specific subject or marks in total, this is considered as a variable. Lots of psychological variables we have, like emotional intelligence, social intelligence, self-esteem, self-efficacy, digital competence, screen time, nomophobia, prosocial behavior, social salience, emotional bond, parenting style, study habit, test anxiety, n numbers of variable we have listened to, we have heard of. Do you remember all these kind of variables? You can also write down some of the variables that you know other than what I have mentioned here. Right, now, so consideration regarding the variable, you got an idea now. Now, when we come to some other aspects of a variable, this is also very significant. Levels of measurement of a variable. In every research, we consider the specific variable in one or the other way. One way is it considered either as a nominal variable or an ordinal variable or an interval variable or as a ratio variable. This is very significant before we discuss something about different statistical analysis, and chi-square is one of them. Nominal variable is for the namesake. When we classify the variables into different categories, that we call it as nominal variable. For example, type of management of the schools. Type of management of schools. Generally we look into completely private, I just mentioned PVT, private, self-financing, self-funded schools. We have another category, government supported schools, government aided schools we have. Purely government managed schools. These are the three categories of schools generally we have in Indian context. So here, for identifying the variable, we can put number for the variable. This is considered as number 1, aided is considered as number 2, and government is considered as number 3. There is no weightage at all. Third, government I mentioned as third, doesn't mean that government is substandard, government school substandard, nothing else, nothing like that. Private, I have given number 1, that is not a meaning of any value rank. Just for classification, I can put it in the reverse order also. This can be given 3, this can be given 1, this can be given 2. This is also possible. I can given 3, 1, 2 as well. So this is simply the categorization, classification. Okay, this is what we call it as, this kind of variables we call it as nominal variable. Another is ordinal variable. We are taking ranks, rank or order of the occurrence, order of the specific variable in certain case. First rank is not equal to second rank. You cannot put second rank for the first rank or first rank for the second, because it has its own value, it has its own magnitude. That is ordinal variable. For example, India's GDP. For example, India's development rank of its various states. If I say Uttar Pradesh is number 1, I cannot put Himachal Pradesh as number 1, because Uttar Pradesh is number 1 in certain parameters. So it has its own value. Based on certain characteristics, it has been given the title number 1. Right? So this way, if the order has its value, it is ordinal variable. In certain cases, interval matters. That is, everyone is having its own property. Suppose mathematics and its achievement. In marks, out of 100, one got 80, the other got 89, the other got 33, the other got 100 out of 100. So these are various marks. As such, we are considering the total number or total marks. This is actually interval variable. As such, we are considering the marks, and accordingly this is called as interval type of. In ratio kind of variable, that is the fourth variable, there is a property that is absolute value of 0, absolute 0. Absolute 0 means absence of a specific element or a specific construct or specific observation. That in certain cases we can use that. For example, attendance in a specific program. If a person got 0, means absolute 0. He has not attended the sessions of the class at all. That is absolute 0. In certain cases, for example, academic performance is not having absolute 0. It is a relative 0. So it will be in interval consideration only. Now let us come to the consideration of today's lecture, that is chi-square. See, what is chi-square? It is a statistical tool used to determine if there is a significant difference between observed and expected frequencies. For example, a tossing of a coin. So how many heads you got, how many tails you got. So here, or you are just taking an example of, if you are taking another example of, you are just throwing a stone above your head level, throwing a stone above your head's level, and you started catching. So you repeated it 20 times. How many catches you got perfectly? How many you missed? How many catches you missed? So here, there are two frequencies: catches successful, catches missed. So what is the association between these two? This way, a chi-square test uses to determine whether there is an association or significant difference between observed and expected frequencies. For example, I have just given this. It is used for categorical data only, that is nominal data only. That is why we have discussed nominal data. It is used to test the relationship between two variables. Relationship between two variables. Got it? Yes. And certain conditions in chi-square. The data must be in frequency form, not scattered. It should be in frequency form. The observations must be independent. Similarly, the data must be from a sufficiently larger data set or larger sample. This is also a concern, and it should be categorical. Categorical data, we mention it as nominal data, nominal variable. and not the continuous variable. Nominal variable, categorical variable, we can mention it as nominal variable. It should be nominal and not continuous. What is continuous? It is interval scale, interval level of measurement. It should not be interval, it should be nominal in terms of its level of measurement. This is something about what is chi-square. Now, again, some of the other readings about chi-square. It is a non-parametric test. You must have learned about parametric and non-parametric tests. Certain tests are non-parametric in nature. For example, if you deal with nominal and ordinal data for major kinds of statistical analysis, you have to use non-parametric test. So we are using nominal data in chi-square, so it is a distribution-free statistics. Chi-square is a non-parametric test. Again, it is designed to analyze the group difference when the dependent variable is measured at nominal level. We have already mentioned the same thing. Yes, it is a robust with respect to the distribution of data. It is one of the robust techniques when we talk about the distribution of data. These are all something about chi-square. Again, some of the very significant things about chi-square. Chi-square does not require equality of variance among the study groups. Say for example, if you go for t-test, if you go for analysis of variance, one-way ANOVA or two-way ANOVA, you need homoscedasticity in your data, or we call it as equality of variance. This is not required in terms of chi-square test. This homoscedasticity or equality of variance among the data set, this is one of the parameter for parametric test. So we have already mentioned chi-square is a non-parametric test, and hence it is not required any assumption like homoscedasticity. Got it? Again, it permits evaluation of both dichotomous independent variables and multiple group studies. These are the concerns when we talk about chi-square. Again, chi-square is a test of independence, and it is used to determine whether or not there is a significant association between two categorical variables. You must be surprising. I am just talking about many things, but there is no example. How can I give example with this? Let me give a data table for you to clarify. Independence is this is the test of independence. The chi-square test of independence is used whether or not there is a significant association or difference between two categorical variables. Let me give an example. Suppose you have two categories of group people based on locality. Suppose it is a college group of students. So you have first group, they are from urban background based on locality. The other group is from exclusively rural background. Two categories of students, college student, urban and rural. You are asking something about their opinion regarding significance of joint family. Some question. Joint family is crucial. Joint family is inevitable for successful development of a child. This is a concern for you. You are asking whether joint family, whether they support it or not. So the responses are given in a scale of 3, that is agreement. It is agree, one category of response. Cannot say, it is another category of response, and the other is disagree. So 3 category of response. Joint family is crucial for development. Do you agree? Do you disagree? Whether you cannot say either agree or disagree. This is the option. So how many students mention agreement? How many of them from rural and urban mention disagreement? How many of them are in the category cannot say. This is the thing. So the concern is agreement versus locality. So what is the concern of the research problem here? What is the concern of research problem here? It is agreement versus locality. Locality of residence based, we have two groups, urban and rural. Agreement based, we have three categories of opinion. Whether there is an association between these two categorical variables, agreement and locality. This is actually what we are doing in chi-square. Got an idea? Yes. Again, what are the assumptions of chi-square? For every statistical test, there are certain assumptions. As a student of statistics, as a researcher, you have to see whether my data set has fulfilled all the assumptions. Then only you can go ahead with the same statistics. This is mandatory in statistical analysis. What are the assumptions related to chi-square? I am just mentioning 4 basic assumptions. One is, the first and foremost assumption of chi-square test is both the variables are of categorical in nature. What is categorical variable? Yes, you know that it is nominal variable. Both x and y, both the variables of your study should be of categorical nature. Then, what is about second assumption? How do you mention the second assumption? All observations should be independent. We should have a concern that all the observations are independent of their existence. Every observation in the data set is independent. The value of one observation in the data set does not affect the value of any other observation. So that concern is all the observations are independent. You got the idea, second assumption. Keep the note of the second assumption as well. Third, assumption number third, related to chi-square we discuss now. Cells in the contingency table are mutually exclusive. There should not be two opinions. There should not be two people in the same cell. What I mentioned, you just confused. Do you get confusion? Let me remove the confusion by putting it. Example we were having, that was against locality. We were talking about locality. What was the categorization we were having? Yeah, the one is urban, group of urban population. The other is group of rural population, right? This is the two category. What were the responses for us? We were having 3 category of response. This table what we generate is known as contingency table. Okay. So this is the table that we have as per that specific data. In the locality wise, urban and rural, and opinion, we have agreement, we have cannot say, and we have disagreement. I just mentioned A, C, and D. Agree, cannot say, and decide. The number, for example, in the urban category, we were having 40 students. In the rural category, again another 40 students. So we were talking about urban category, joint family is required for the development of, no. They mentioned that 5 people have mentioned it is required. 10 people have mentioned it is not required. Okay. And rest of the 25 mentioned it is not required. It is okay. Altogether 40. Right. This is what the N, total number of responses. In the rural category, 30 people mentioned that yes, it is required. 5 people mentioned that cannot say. 5 people mentioned that it is not required for development. They disagree. So here, all the exclusive means no individual has 2 opinions. Altogether, we are getting 40. Again, altogether in the urban, we are getting 40. So, everyone is exclusive in the kind of their opinion. For example, cells in the table are mutually exclusive. An individual cannot belong to more than one cell. Got it? That is, out of 40, 30 students of rural opine that family of kind, that is joint nature, is required for the development of the child. It will be enhancing, that is the concern. Okay, again 5 people mentioned cannot say, again another group of 5 people mentioned that it is not required, or they disagree. In the case of urban also we have mentioned. So you got clarity regarding that. Yes. Now the third assumption, expected values of cell should be 5 or greater in at least 80% of the cells. So the value should be 5 or greater. We have mentioned here the values this way, the value should be 5 or greater. That is the concern of chi-square. It's a third assumption. The expected values of cells in contingency table should be 5 or greater in at least 80% of the cells, and that no cell should have an expected value less than 1. I am talking about expected value. So, large sample should be required, not very small sample. Relatively larger sample we need to operate chi-square. That is a concern. Okay, got it. Again, these are the 4 assumptions regarding chi-square. What we have seen, assumption number 1, both variables are categorical. Second one is all observations are independent in nature, and third assumption is cells in the contingency tables are mutually exclusive and no person should be in more than one cell in terms of their concern or their consideration in the cell. It should not be overlapping. And fourth assumption is expected values of the cells should be 5 or greater in at least 80% of the cells. Got it? This is a concern. Now, when we talk about chi-square in general, you got an idea about what chi-square is. Chi-square is a significant statistical test, and it should all be it. Chi-square is a significant statistical test, and it should follow with a strength statistics. We should have a strength statistics in chi-square. And the Cramer's V, you must be known about Cramer's V. Cramer's V is generally used for strength test of chi-square. Once you do a statistic like t-test, independent sample t-test, what is generally we use? Cohen's d we generally use for identifying the strength of the statistics, considering the significant strength of the significant difference between two variables. That is, two groups will be tested for significant difference through t-test, and later we will go for a Cohen's d or any such kind of significant strength testing. Here for chi-square, the test of significant strength is Cramer's V. Cramer's V is most commonly used for identifying the strength of chi-square statistic. Okay, you got an idea about it. Now let us conclude. What is chi-square? Chi-square test of significance. It is also known as Pearson's chi-square, as it is developed by Karl Pearson's chi-square test, or simply we sometimes call it as chi-square. Yes, it is one of the most widely used statistics for testing the hypothesis when the observations are nominal in nature. This is the simple generally we use for chi-square, an expanded version of x and square, chi-square we use it. Okay, you got it, chi-square. Okay, in another lecture we will discuss in detail how to operate chi-square very specifically. Again my question comes at the end. Lots of statistical calculations we learn, one or the other. Lots of statistical calculations we learn. Measures of central tendency, dispersion, test of significance between mean, parametric, non-parametric, normality, lots of confusion. Sometimes you got it. In my lecture regarding chi-square, I have just discussed the basics of chi-square test. What it is, what are the significance of test of chi-square, significant assumptions. Did you get it? Yeah, sometimes your opinion would be yes. I'm so happy if it is. No, I won't be happy, but see, read it again, understand, go through the lecture once again. Definitely, you will get an idea regarding what is chi-square, what are the basics of chi-square, because it is essential to go ahead with the calculation part of chi-square. I hope you have enjoyed the lecture. Thank you. Have a joyful learning.